All right, it's officially 12 o'clock. We'll go ahead and get started. This week we are covering two full modules, modules 6 and 7, covering web work sections 10 through 13. Now, as I said in my email, which you may or may not have read, I will be posting this live recording as usual. And then I'm also going to post two live sessions from earlier this semester when I did these two modules separately. So you don't have to watch those other videos. They are simply a resource. If you would like to see more Becky Special live examples instead of the videos that go with the packet, they're there for you. Watch them if you want, don't if you don't. It's up to you. I just want to make sure you have the resources that you need that may help you. So you've got 4 web work sections. This is going to be an intense week. You are going to have to put forth some time, and I recommend you start sooner rather than later with 4 full sections. You also have a report, dosage calculations. Now, I don't want you to be scared by that report word. The reason it starts with report instead of Excel is because Excel is not required. You can do the dosage calculation assignment in Word if you would like. The report part of it is a couple sentences. You're going to answer a couple questions. It doesn't have to be long. It just has to answer the questions in. And I can show you that in the course if you want afterwards. And we will do a problem in this live session that will kind of walk you through, and I will tell you this is what the dosage calculation assignment is about. And then you will have an Excel assignment about histograms and bar graphs, which goes with section 13, and I do have an Excel help video for that, so I will post that video as well. 2 quizzes this week because we're covering 2 different modules, 1 discussion board, and then Project 2 is officially assigned because Project 2 goes along with Section 12. Again, I have help videos to get you started on Project 2. Now, with that being said, Project 1 should be coming due soon. Yep, I believe it's the 28th, so that is a week from tomorrow. If you haven't started Project 1, I highly recommend you add that to your things to get started on, because if you have questions, you want to get those questions to me sooner rather than later so that we can work out any bugs that there might be. So there you go. Again, if you have any questions, let me know, but a big week this week. But you guys got it. I have no fear, no fear. So we will be going through kind of an abbreviated double PowerPoint today. Obviously can't get through all of them. There's just no way. I usually do an hour on each of these PowerPoints. I'm going to do them both in an hour. So be ready for the roller coaster. Of course, you're going to interrupt me if you have questions, comments, concerns, or suggestions, and we'll go from there. So sections 10 and 11 go together. They deal with conversions, and we're going to just jump right in. Does anybody have any questions before I jump right into the math? Usually you guys are pretty good about either speaking up or typing. So, okay. In your packet, you will notice if you go back to page 245 is a yellow sheet of paper. That yellow sheet of paper is your formula sheet. And both sides, 245, 246, that is what you will be given when you go in to take exams 2 and exam 3. So it's going to be very important that you use page 245, 246 as we move through the rest of the sections, because that's what you're going to have for the exam. And so you want to make sure you're comfortable with what you will have. So as we get started here in section 10, we get into the concepts of identity ratios. So when we're converting with the U.S. customary units of measurements, which is the top part of page 245. So if you look at the top of that yellow sheet, you're going to see that first big section of rectangles is U.S. customary units. So we've got length, volume, and weight, and you will be asked to work within all 3. Now, when you get into web work, if you get to questions and you're stuck and the help videos aren't helping, email me. Email me early and often. I'm spending a lot of hours this week in my office, which means I'm on my computer. So if you have questions, send me an email. Take a picture of your work, send it to me. I would love to help you. Okay. So identity ratios, what those are, and first of all, I obviously can't spell, that should be a T, identity ratios. That basically means if I have the ratio 12 inches over 1 foot, This is an identity ratio because the numerator and the denominator represent the exact same thing, but they're given in different units. So identity, right, it means itself. You know, you look in the mirror, it's your identity. It's the same thing. So 12 inches is 1 foot. Now, the thing to be careful of, or to be aware of, I should say, is that you could also write that as 12 feet is 1 foot is 12 inches. Notice it's just the position change. And that's going to matter as we get into the dimensional analysis piece of this starting on the next slide. So when I refer to identity ratios, I simply mean a numerator and a denominator that mean the same thing but are given in different units. And if you look at page 245 at the top, all of those equalities are identity ratios. So looking in the volume section, we know that 1 pint is the same as 2 cups, right? And that can also be written, it's an or, as 2 cups over 1 pint. Every identity ratio can be written 2 ways, and that matters as we move into the next slide. So now we're going to get into a couple problems, and again, if anything doesn't make sense, you want me to talk about something in a different way, all you have to do is ask. So my pedometer said that I walked 11,520 feet yesterday. How many miles is this? A good rule of thumb that pretty much always works is that you always start with what you're given. So in this particular problem, I will start with 11,520 feet. And because when we just got done talking about identity ratios, we're talking about fractions, and we need to start with a fraction. So how can I make that 11,520 feet, how can I turn that into a fraction? Anybody awake? Sometimes I ask questions to see if anybody's awake. No? Nobody's awake? Can you at least raise your hand if you're listening? Ooh, okay, there's one hand. Okay, well, I got one. Maybe the rest of you are not paying attention. Whatever, that's fine. Okay, so to make that a fraction, we put it over 1. Oh, good. Thank you. Thank you, Jennifer, for responding there. At least okay, good. All right. So when you think about fractions, because this is kind of the basis of all section 10 and 11, if we think about we're multiplying fractions, I want to get rid of feet, right? So this is what I want to go away. Well, when we multiply fractions, we can reduce. Think about reducing fractions. So if I want to reduce the feet to make them go away, right now feet are located in the numerator. To make them go away, I would put them in the denominator because that will make them cancel out. Think about canceling fractions, numerator to denominator. So when I look at my page 245, my formula sheet, I see in that first spot, I can convert feet to miles. So I know by labels, feet to miles. And I know there are 5,280 feet in 1 mile. So that's the identity ratio I wanted to use because I want these feet to cancel out and I want to move into miles. So when we're looking at this, if you think about the fractions, right, we multiply straight across. So I end up with 11,520 on the top and 5,280 on the bottom, and my label is miles. We need to simplify this, so we're going to go ahead and divide. So if I divide 11,520 divided by 5,280, I end up with approximately 2.18 miles. So the general rule of thumb, if you start with this number, anything in the numerator you multiply, anything in the denominator you divide. So because the 5,280 is in the denominator of the second fraction, we would divide. So we could have just gone 11,520 divided by 5,280, and that would give us our 2.18 miles. Okay, I call this an easy problem because it's one step. That's how I identify easy, one step. Anything more than one step becomes more difficult. Obviously, the more steps you have, the more difficult it is. So this is an example of an easy problem. Now, let's go to a difficult problem, which means multi-step. Again, if you have questions, comments, concerns, or something doesn't make sense, please interrupt me at any point in time. So I bought a gallon jug of juice. How many cups is this? Okay, so again, we always start with what we're given, and we're given a gallon. Hopefully you remember from your life that a gallon is 1. So I end up with 1 gallon of juice. I make it a fraction. Now, if you look at your sheet, gallons do not go straight into cups. They don't. If we look at our top thing, gallons go to quarts. So I want to change my gallons to quarts. Think about placement. Your labels should guide the work in these problems. So if I have gallons on the top, I want gallons to be on the bottom so they cancel out. So 1 gallon is the same as 4 quarts. That process right there makes my gallons go away. Now I'm in quarts, but that doesn't answer my question. My question is cups. Well, when I look at quarts, I can change quarts to pints. So I have quarts on the top in green, so I'm going to put quarts on the bottom in orange, and that means 1 quart is 2 pints. Well, again, that step right there makes my quarts disappear, but now my label is pints. Again, that doesn't answer my question. So continuing on, I know that 1 pint is 2 cups. Notice I put pints in the denominator so that they would cancel out. Pints in the top cancel out pints in the bottom. And now my label is where I want it to be. So if I start at my first number, everything is in the top. All my non-1 numbers. So 1 times 4 times 2 times 2 gives me 16 cups. So 1 gallon of juice gives me 16 cups. Okay. Does that make sense to everybody? Have I lost anybody in the process? Because that right there is the fundamental backbone of sections 10 and 11, is being able to draw these out, write out your steps, and let your labels guide your actions. Okay, you guys are pretty quiet today. We skip 3, we go into metric conversions. So the next rectangle down on your page 245, you see the metric relationships. And really the metrics are all about counting. So metric units deal with powers of 10. And because they're powers of 10, think about scientific notation that we did in Unit 1. With scientific notation, you could simply move your decimal right and left and it worked because of powers of 10. Same thing with the metric system. Now, the one thing with the metric system, the unit in the middle, this is liters, grams, and meters. So depending on, liters is volume, grams is weight, meters is length. When we get to section 12, we're also going to talk about watts in terms of CO2. So it also would be watts is the unit. And then everything, the 3 units to the left, 3 units to the right, those are prefixes, right? Kiloliters, kilometers, kilograms, centimeters, centigrams, centiliters, milliliters. All of these things that we've definitely heard of, but they're all the prefixes for these pieces. Okay, so let's go ahead and look at the easy part of how to do some of these problems. So if you can count, you can go with metric. If you can't count, we've got a bigger issue. So we have 380 centimeters, and we want to change that to hectometers. All right, so here's the key. And the nice thing is, again, you're going to have page 245, so you can use that as your base. You will be given a page 245 at the exam. You do not get to bring your own. I'm sorry to tell you. Okay, so just like with the U.S. customary, we start at what we're given. So we're given centimeters, which is here. Start at centimeters. I want to go to hectometers. Which direction would my X have to move to get to hectometers? Right or left? Left. Thank you. Yes, people are listening. Good, good, good. So, and this is the easy part of this. So you locate centimeters, you put an X. I need to go left to get to hectometers. And I need to go 1, 2, 3, 4 units left. So if my initial number is 380, we know that if we do not see a decimal point, it's automatically at the end. So my decimal point comes at the end. I need to move it left 4. So 1, 2, 3, 4. My new decimal point goes there. I have one empty hump, which makes it a 0. So this is the same as 0.0380, or you can leave that last 0 off, and that's hectometers. So it's all about counting. If you can count right or left, you can do metric units. Okay, you try one. Try a metric. Change kiloliters to deciliters. And our answer is 45,000 deciliters is correct. Because we start at kiloliters, which is here. So I need to move to the right 1, 2, 3, 4 places. So if you move your decimal right 4, 1, 2, 3, 4, you add 3 zeros, and 45,000 it is. Good. There's metric. Now, we do what we call jump across the pond. There are times when you're going to start in either U.S. customary or metric, and you've got to go the other direction. So jumping across the pond is when you have to convert between U.S. customary and metric. That's a Becky-ism. You watch any of my videos, we're going to talk about jumping across the pond. And again, there's going to be easy problems and there's going to be difficult problems. So let's start with an easy problem. Again, easy means one step. That's why it's easy. I weigh 170 pounds. What is that in kilograms? Well, you start with what you're given. And some of this has to be thought process on your part. So you know that pounds is US. You know that kilograms is metric. So you should say right away, I have to jump across the pond. I need to look at this. Some of them are going to be easier than others. So if I start with 170 pounds, again, I make it a fraction. Because when you're jumping across the pond, you're using metric or US customary, so you're going to have to use identity ratios. Now, if you look at the weight in this formula sheet, and this is part of the reason why I do this problem, you will notice that 1 pound is 0.4536 kilograms. It's not the standard 2.2 kilogram or 2.2 pounds is 1 kilogram, which is what like a lot of medical fields use. That's not what we use in this course. And if you try to use that in this course, you're going to get a slightly different answer because they're estimated, and that will throw off your answer, which really sucks. So just use the conversions on the yellow sheet. All right, so I change pounds to kilograms with that conversion. I multiply straight across. And does anybody have a calculator that can tell me how many kilograms that is? Be nice if I could talk. Amber says 77.112. I'll take it. And that is kilograms. All right, again, an easy problem. I feel like you could all do this because it's one step, right? One step, not too shabby. Let's do one that is more than that, which would be number 9. Ounces to milliliters. Again, you notice ounces is US, milliliters is metric, so we have to jump across the pond. Now, if you look at this, ounces and milliliters, we're talking about volume. Volume is the middle rectangle in those boxes, and you can see under the conversion between US customary and the metric system, there's only one way to jump from US to metric, and that is quarts to liters. So my first job is to get ounces to quarts. Okay, so that's what we're going to start with. I go 16 ounces over 1. Well, if you look, so now we need to go ounces to quarts. That's our goal. I know that ounces have to go on the bottom, but ounces go to cups. So I know that there are 8 ounces in 1 cup. That makes my ounces go away. But that's not quarts. So then I can say, well, I know there are 2 cups in 1 pint. That makes my cups go away, but I'm still not in quarts. So then I do one more step and I say, well, I know there are 2 pints in 1 quart. That makes my pints go away. Now my label is quarts. That's what I wanted, right? Because once I have quarts, then I can say, well, I know that 1 quart is the same as 0.9464 liters. And at this point, you're like, son of a biscuit, this is a pain. You're right, it is. This is the most difficult problem that you will see, the one that we're doing right here. So at this point, you can see that I have 16, that's a horrible 6, divided by 8, divided by 2, divided by 2, times 0.9464. This gives me how many liters I have. So I'm going to give you just a second, so hopefully you're playing along. If we're looking at how many liters we have, we should end up with 0.4732 liters. Unfortunately, that does not answer the question because the question says milliliters. So then you go to your metric system and you say, okay, if I go from liters to milliliters, I have to move right 3 places. So I take my decimal and go 1, 2, 3, and that gives me 473.2 milliliters. So when I say the most difficult, we had to convert within US customary and within metric and jump across the pond, all in the same problem. So that is by far the most difficult problem that you will see. But I wanted you to at least see something difficult so that we could go from there. Okay. All right, questions on section 10. So 22 minutes on section 10, which is a lot, but that's great. Okay. I'm sorry that today is a lot of me yammering at you and not much me asking questions, but I want to make sure we definitely have time to get through everything. So in section 11, it starts with temperature. I am not going to cover temperature in this live session. There are videos of the temperatures, and I think that you guys are more than capable of watching that one video and being able to apply that. So section 11 deals with more of what we just did, but now we're dealing with area and volume. So just to kind of refresh on what that means, when I talk about area, I'm talking about I want to paint this wall in my house, right? If I want to fill this up with paint, that's area. Hopefully you stay inside the lines when you paint. But if I have a rectangle, how do I find the area of a rectangle? Anybody remember? Length times height, yep, or length times width, base times height, something like that. Yeah, the 2 sides, you're multiplying them together. And if you're thinking, oh crap, I don't remember, don't fret. If you look at the very bottom of page 245, you see a spot called Other Useful Information. Area of a rectangle is there, area of a circle, and volume. So area is, a flat surface. But you will see if we had 7 inches by 2 inches, well, if I multiply those together, we all know that 7 by 2 is 14, but inches and inches, that means there are 2 inches. So you can see we now have square units. Similarly, if we're talking about volume, volume is 3-dimensional. So if I say I've got a box here, that's a pretty good 3-dimensional shape using a mouse. Let's say this is 3 by 1 by 4, and they're all in inches. Well, volume of a rectangular prism is length times width times height. Excuse me. So if I would take 3 inches times 1 inch times 4 inches, well, 3 times 1 times 4 is 12, but you can see I have 3 labels of inches, which gives me inches cubed. And those units are going to be what causes now issues as we move into conversions. Because if I have 3 inches, inch, 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 and I want to convert that, I'm going to have to do 3 conversions to cancel out all 3 pieces. All right, let's do some examples. I do this example primarily because you're going to do one very similar to this in web work. So what is the area of a sheet of paper in square feet? Well, if you don't know the dimensions of a sheet of paper, you can't do this problem. So do any of you know the dimensions of a sheet of paper? Very close, Amber. It's actually 8.5 inches by 11 inches. That is the standard of a sheet of paper. And you're gonna need that for web work. So if you didn't know that off the top of your head, you might want to write that down so that later when you go to do your homework, you have that. And if you don't remember, shoot me an email, I'll tell you. Okay, so we want to find the sheet of paper in square feet. Well, the first thing we can do is we can find the area. What is the area of the sheet of paper in square inches? Let's start with that. So we just start with 8.5 times 11. What does that give us? 93.5. Very good. So we're at 93.5, and my unit is inches squared. Again, we have 2 inches, therefore it's inches squared. Now, I want to change square inches to square feet. We know from our page 245, and maybe just because you are alive, that there are 12 inches in 1 foot. Now you'll notice I put the inches on the bottom so that they can cancel out, numerator to denominator. But the problem is in the numerator, I have 2 inches. That's what the squared represents, that the inches are there twice. And therefore, I want to do this conversion 2 times. Same conversion, I'm just doing it twice. Because inches and inches, there's the 2 inches, so it cancels out with the 2 inches. So I will take my 93.5 divided by 12, divided by 12. And what do I get for the area of my sheet of paper in square feet? Yeah, we'll go ahead and round that to 0.65 feet squared. So again, you're letting the labels guide you. So if your label is square units, then you're going to use 2 conversions to change it. Okay. Amber's doing a great job of replying. I hope everybody else there is following along, doing okay. No questions, people, everybody okay? Okay, so let's do a volume problem. So that one was area, this one is volume. A bag is 18 by 16 by 2 feet. What is the volume in cubic feet? Okay, before we even get started, what do you notice about this problem? Inches and feet, exactly. We have 2 different labels, and that's not okay. If you're going to be doing conversion problems, all of your labels need to be in the same units. So you have a decision to make at this point. You can either change everything to inches, or you can change everything to feet. Does anybody have a preference? The only issue is you have to make sure you're staying as close to the actual answer as possible. So you just want to be careful about that. So if we're looking at this, what do you want to do? Anybody who wants to make the decision about what we change to? Because I'm sick of making all the decisions. Inches, all right. I like that people make decisions. So we're going to change to inches. Therefore, 2 feet is how many inches? A lot of people just know that. 24. There we go. Okay. So now everything is in inches. Now we can play. Now we can find volume. Because remember, volume is length times width times height. So 18 inches by 16, that's a times sign, times 16 inches times 24 inches. What is the volume of my bag? 6,912 cubic inches, right? We've got to have that 3 up there as the exponent on the inches because you multiplied 3 inches together. Does that answer your question? The answer to that is no. Because why? We're in cubic inches and we want cubic feet. Very good, exactly. So how do we go from cubic inches to cubic feet? Process is just inches to feet, right? So we know inches are going to go on the bottom. So if you see, we have inches in the top, so to get rid of them, they have to go on the bottom. So 12 inches is 1 foot. How many times do I need to do this conversion? 3 times. Excellent. Does everybody understand why we have to do this 3 times? Because that's crucial, right? We have these 3 inches cancel out with these 3 inches. The reason this is a 3 because of these 3 inches right here. All right, so they all cancel out. So that ends up, if you look at the math then, 6912, all of these 12s are in the denominator, so we're dividing by each one. So 6912 divided by 12, divided by 12, divided by 12, gives me a beautiful answer of 4. Yep. 4 feet cubed. Exactly. Very good. Very good. All right. I think you got that process down. I hope. So now let's go to a cylindrical shape. Oops, wrong button. A soup can is 5 inches tall with a radius of 2 inches. What is the volume in cubic centimeters? Now this is a cylinder. So volume of a cylinder is pi times the radius squared times height. And again, volume is cubic units. And if you look at it, the radius is there twice. And then we have the height. That's where the 3 different labels come from. Radius twice, height once. So when you're looking, you're given this soup can. If I draw my cylinder here. Radius of 2, height of 5. Remember, the radius is from the middle of the circle to the outer edge. So if I find my volume, now for pi, what's the rounded estimate for pi if you don't want to use a pi symbol? 3.14, very good. So you can use either one. I'm pretty sure you can use either one in your homework, whatever floats your boat, you should be okay. So we have pi times the radius, which is 2. We're going to square that, which is the same as 2 times 2. And then we're going to multiply that by the height, which is 5. So I'm going to let one of you tell me the volume of this particular can. Let's go to 2 decimal places. I did not get 197.19. Did anybody else get something different? I got 62.8, yeah. Amber, I'm not sure. There we go. 62.8, and our units are inches cubed. Again, because we have the radius here, this is 2 inches. We squared it, which is another 2 inches, and then we had the height, which is 5 inches. Okay, so 62 inches cubed, but we want to go to cubic centimeters. Can we go from inches to centimeters? right? Inches is U.S. customary, centimeters is metric. So if you look at your yellow sheet, we want to jump across the pond, right? If you look at jumping across the pond in that first, this is length, inches, centimeters, length, you see that 1 inch is 2.54 centimeters. And again, I'm going to do this 3 times because my label is inches cubed. So that step there, 1 inch, 2 inch, 3 inch, cancels out with my cubic inches. And what is my volume in cubic centimeters? Oh, there we go. 102911 cubic centimeters. Now, one thing I want to point out, if you had used the pi symbol or 3.14, you might be slightly off from that. Like, I don't remember what I used on my paper, but I got 1029.63. So I got a number slightly off because I used the other one. I guess I probably used the pi symbol and you probably used 3.14. They're both okay. The tolerance should be set in web work that you're going to get credit no matter which one you use. So don't worry about that. You use whatever one makes you feel the most comfortable. Okay. All right. Questions about volume. Oh, wrong button. Okay. So we are now going to go to 16. I'm skipping over all of that of water. You can watch videos for those if you would like. But we're going to jump into rates. Rates simply mean that we are going to have labels on the numerator and the denominator. So we're still in section 11. I ran 5.3 miles per hour. What is this in meters per second? Well, remember way back section 4, we talked about the word per being a fraction bar. So if I had 5.3 miles per is the fraction bar, then I have 1 hour. So you can see now how I have labels in the numerator and in the denominator, and I might have to change them both. So when I look at what I want meters per second. So I have to change miles to meters and hours to seconds. And this can be a little tricky. So once again, we're getting into this is a more difficult problem than you're probably going to see in your homework, but I do that on purpose because I think that you should see your harder problems in class, and I think that's good for you. Okay, anyway, so miles is US, meters is metric, so I know I have to jump across the pond. I'm going to do that last because I don't know about you, but hours to seconds, I think I can do that pretty easily. Because if I want to get rid of hours, notice how right now hours are in the bottom. So if I want to get rid of hours, they have to go up top, right? They're always in the opposite positions. I know that 1 hour is the same as 60 minutes. It has been my whole life. And that right there makes my label of hours disappear. Well, now I'm in minutes, and I don't particularly want to be in minutes. I want to be in seconds. Well, I know that 1 minute, again, opposite positions with my labels, is the same as 60 seconds. That makes my minutes go away, and now my label in the denominator is seconds, which is exactly what I want. So my denominator is satisfied. I don't have to change that label anymore. Now I'm ready to attack my numerator. So when I look at miles, I come way back over here to miles. I want to get rid of them. So I put miles in the bottom. And again, remember, I want to jump across the pond. Well, if I look, I can jump from 1 mile to 1.6093 kilometers. That gets me out of miles, and it gets me into the metric system. And once I'm in the metric system, then I can just move my decimal. So I'm going to go ahead and do this math. 5.3 divided by 60 divided by 60 times 1.6093. When I do that, I get a pretty small decimal. 0.00 237. I'm just going to go ahead and round because I'm a little bit lazy. And that's kilometers per second. But that does not answer my question. And this is somewhat why I like to write this part over here of what's my goal. So if I want to go from kilometers to meters, right, looking at your metric system, kilometers are way over on the left, meters are in the middle. That means I need to move right 3 places. So if I take my decimal point and go 1, 2, 3, that gives me a final answer of 2.37 meters per second. It's pretty in depth. There's a lot to that, but there it is. Okay. Okay. I only have one more problem I want to do from section 11, and I know you're looking at the clock going, you need to talk faster. Don't worry, I have a plan. It was laid out before the class. I hope nobody has any questions on that. Nobody's asking any. So the last one we're going to do in section is number 18. And this, my friends, is what your report dosage calculation is going to kind of be about. All right. In that report, you're going to be given, I don't know, I think it's like 10 patients. And you're given their weight in pounds and how much drug they were supposed to get, their dosage. And you're supposed to find out if these patients have been overdosed or if they were given the correct amount of drugs. Okay, so we're going to do the math right now by hand. You can use Excel to program to do it for you, or you can do it all by hand. It doesn't matter, right? You just have to do it and then tell me who's been overdosed and why. Okay, so here's the big part of this. We know that Steve weighs 188 pounds. His drug dosage is 25 milligrams per kilogram. Again, remember that per means fraction bar. It's also important to notice it's given twice a day. We're trying to figure out the amount in each dose. There's a lot going on in this problem. So I want to just draw your attention. And this is true in real life, right? The amount of drugs you get is based on your body weight. You don't give the same amount of morphine to a 100-pound patient as a 400-pound patient. Different weights require a different amount of drugs. So the drug dosage is based off the weight in kilograms. So we have to first say, well, our weight of our patient is 188 pounds. I need to change that pounds to kilograms, because if I don't know the weight of Steve in kilograms, I don't know how many drugs to give him. So pounds to kilograms is jumping across the pond. So that's my first step. I go to my jumping across the conversion pond here, and I know that 1 pound is 0.4536 kilograms, just like it was the last time we did this use that conversion. That makes my pounds go away, and I'm in kilograms. Now that I know how much he weighs in kilograms, or I have the formula to find out how much he weighs in kilograms, now I can use this identity ratio, essentially. I know that he gets 25 milligrams per is my fraction bar, 1 kilogram of weight. So for every kilogram of weight, he gets 25 milligrams of drugs. And that right there makes the kilograms disappear. This now gives us total milligrams. So if we multiply 188 times 0.4536 times 25, what is the total milligrams Steve should be given in a day? Go ahead and round to the nearest milligram, please. $21.32 is absolutely correct. So 21.32 milligrams, that's total for the day. If he's given this twice a day, how do you figure out how much goes in each dose? Don't overthink it. Yep, divide by 2. If you get 21.32 total and you get it 2 times a day, you divide it by 2. So we should end up with roughly 1,066 milligrams per dose. And that's what you're doing in this report calculation. You take each patient and you find out how much. So you're going to do the math, figure out how much they should get and then you're going to compare it to the amount that they actually got, that they give you, and then you're going to tell me about it. Okay, so that's what that report is about. Make note. Okay, and that is the end of section 11. You are going to find that section 10 and 11 in web work are pretty lengthy. There's lots of types of problems. So, if you get to one and you're stuck, shoot me an email about it and then move on to a different problem, and we'll kind of go from there. Okay, so let's jump into section 12 as soon as I get this. There we go. Section 12 gets into carbon dioxide emissions. And as I mentioned at the very beginning, 46 minutes ago, which seems like forever ago, this section is what Project 2 is based off of. I will be posting a video about it. So once you finish Project 1, you can then get started on Project 2. Project 2, I think, is a little bit less intensive than Project 1. So hopefully that calms your fear a little bit. But we're dealing with carbon dioxide emissions, your carbon footprint based off of gas and electricity. So you will notice again on page 245 on the formula sheet, the fifth big rectangle down, you see carbon dioxide emissions. So from gasoline, 19.8 pounds of carbon dioxide is emitted for every 1 gallon of gas you produce or you use. This identity ratio has to be used anytime you are doing a CO2 problem with gasoline. It has to. For electricity, you produce 1.37 pounds of CO2, right, carbon dioxide, for every 1 kilowatt hour of electricity you use. So we are going to have to find kilowatt hours of electricity in order to figure out how much carbon dioxide we do. So we're going to do a couple of these problems, and then we'll kind of wrap up. So, number 1, I use 17 gallons of gas to get to work each week. How much CO2 do I produce? For some of these problems, at least the gas problems, sometimes I like to work backwards because I know if I'm using gas and CO2, I have to use the 19.8 pounds is 1 gallon of gas. Have to. There's no other option. And I know that I'm using 17 gallons. So I put 17 gallons on the top because, just like before, your labels are going to have to cancel out numerator to denominator. So if the gallons cancel out on the top and the bottom, I can just multiply. Excuse me. So what is 17 times 19.8? Yep. So 336.6 pounds of CO2 is what is produced each week if this is your traveling process. Again, I would call that an easy problem because it's one step. So remember, I call those one-steppers the easy ones. So let's go ahead and do a somewhat more difficult one. The gas ones really aren't too bad, but my car averages 37 miles per gallon. If I drive 400 miles each week to work, how much CO2 do I produce? Now, I want to first kind of focus on this piece right here. Remember, the per is a fraction bar. So this is the same as 37 miles per 1 gallon. Or you could write that as 1 gallon over 37 miles. Because remember from earlier, every identity ratio can be written 2 different ways. All right, so I have those two. I have 400 miles. And the question is, how much CO2? Well, if you think back, CO2 and gasoline, I know we're talking about gas because we're talking about driving. And therefore, I know that I have to use 19.8 pounds is 1 gallon of gas. And the question is, how much CO2? So I know my final answer should be in pounds. And then you can kind of work backwards. Well, I want to get rid of gallons. If gallons is in the bottom, to get rid of them, I have to put them on top. Well, this is the only identity ratio that has gallons on the top. So 1 gallon is the same as 37 miles. That right there makes my gallons go away, which is great, but now I have miles in the denominator. Well, I have 400 miles. So if I come over here and put 400 miles over 1, that makes my miles go away. Now I'm ready to do my math. So 400 divided by 37 times 19.8 gives me how many pounds of CO2? Just round to the nearest pound. 214. So if this is your situation, you burn or create, I guess, you produce 214 pounds of carbon dioxide. Okay. All right, so that's electricity, or excuse me, that's gasoline. Now we go to electricity. With electricity, I would like to draw your attention to page 102 in your packet. I'm also turning to page 102 in case you can't hear that. 102 has a bunch of appliances, kind of categorized as to where you may use these appliances, and then the watts, right? The watts that are when these appliances are in use. So when you look, and you're going to need page 102 for your web work homework, because they're going to have a problem just like number 3, and you're going to need to get those watts from somewhere. So I use my microwave 6 hours a month. How much CO2 do I produce in a month from just my microwave? Okay, so locate the microwave in the kitchen. Where's it at? There it is. If I look, it's about halfway down. And I don't know if you guys have your packets or if they're readily available, but I noticed that my microwave is 1500 watts. Okay. So that's the first step, is being able to find it on the sheet and pull out the number of watts. So if it's 1500 watts, now you have 2 options from here. We need, if you remember, we need to use 1.37 pounds of CO2 is 1 kilowatt hour. So I need to change watts to kilowatts. And a lot of people like to say, well, I know that watts is a unit in metric and kilowatts is left 3. So if I move my decimal 1, 2, 3, this is the same as 1.5 kilowatts. If you watch the videos I do that go with the packet, I do it slightly differently. So if you want to see both methods, watch those videos. So I have 1.5 kilowatts over 1. That was supposed to just be a 1. But I need kilowatt hours. So my next step is to multiply by the number of hours that I'm doing this. Well, this microwave is 6 hours a month. So I just use 6 hours because that's what we want. We want it for the whole month. So this is kind of a spread out problem. But you can see that kilowatts cancel out with kilowatts, hours cancel out with hours, and I'm just left with pounds. So 1.5 times 6 times 1.37, and we are left with approximately 12.3 pounds of CO2. Okay, and that's about the easiest electricity problems that you're going to have. You got to have kilowatts, hours, and then the pounds. So let's do one that's just slightly different. My electric clothes dryer is used 3 hours each week. How much CO2 do I produce in a year? So now we are given the number of hours each week, but our question asks about a year. And so it's those details that are going to may cause you issues. All right, so I'm going to just tell you, a clothes dryer is 3,400 watts. And when you get to project 2, I recommend you use a clothes dryer to make your life easier. You'll understand when you read the project. Okay, so if I have 3,400 watts, how many kilowatts is that? Remember, watts to kilowatts is left 3 units, so 3.4 is correct. So I have 3.4 kilowatts. Okay, now think about the hours. I have 3 hours in 1 week. But that's not what I want. I don't want in a week. That's why I wrote it there. I want the weeks to go away. I want a year. How many weeks are in a year? 52. So I'm going to multiply that by 52 weeks over 1. That makes my weeks go away. Now I have the proper number of hours because 3 hours each week for 52 weeks because there are 52 weeks in a year. Now that I have kilowatt hours, now I can do my 1.37 pounds over 1 kilowatt hour. Kilowatts cancels out with kilowatts, hours cancels out with hours. I multiply all those beautiful numbers across the top, and I end up with roughly 727 pounds of CO2. Okay. All right, that is the last math problem I'm doing. Now I want to give you some information because we're down to 5 minutes. Page 103. Page 103 gives you the watts of energy vampires. So I brought up this new page to talk about energy vampires. Standby mode is energy vampires. Energy vampires are anything that is plugged in but not currently in use. So like right now I'm at work. At my house I have plugged in 2 TVs, 4 lamps, my microwave, my oven, my blah blah, everything is plugged in, but nothing is on because I'm here. And therefore, it's all still drawing power. I'm still paying for the electricity there, but it's way, way less. If you look at the watts on page 103 compared to 102, you can see they are significantly smaller because these are items that are plugged in but not being used. You're going to need that energy vampire list as well to do homework and to do the project. Okay, you will notice that this week also includes section 13, and I did not even talk about it one time. Section 13, I think, is one of the easier sections in the packet. It's one that's a little more intuitive. I believe that if you watch the videos, you will have no problems with section 13. If you watch the videos. That's a big if. Some of you might be able to do it without, but don't just try to do the homework and say, oh, I'm stuck and I didn't watch any of the videos and this is horrible. Well, watch the videos, okay? If you have questions about where to find these videos or if you need help with something, shoot me an email. I'm more than happy to help you, okay? I will be posting about 4 announcements, probably 3 or 4 that have all the help videos that go with this week. And I'm going to post them as soon as this live video converts, so it'll be probably about 20 minutes. But as you're going through things, if you have questions, let me know. And again, do you guys all know where to find the videos that go with the packet? Because sometimes people aren't sure where those are, but I can send you the links to those videos as well if you can't find them. So there's a lot going on. It's a very busy week, but I think you guys are on it. Get to it, start working, and of course I'm here if you have any questions. So 2 minutes to spare. Wow, I just talked nonstop for an hour. I apologize. But do you have any questions for me at this time before we sign off for the day? Or I should say, if you don't have any questions, you're free to go. Go forth and do math. If you have questions, you know where to find me. And yeah, we'll go from there. But thanks for coming. I'll stick around for as long as you need to ask questions, answer questions, and we'll go from there. So thanks for participating. I'll chat with you later.